Hello, good morning, children. Today we are going to start the lesson that is motion in a plane. So, let us start today's chapter. Motion in a plane. Presented by Seema Nigam, Fugitive Physics, K.V.No.1, Armapur, Kanpur. Today's thought: action is the fundamental key to success. So this is one small positive thought in the morning can change the entire outcome of your day. So with this positive thought, action is the fundamental key to success. Let us be in action always. Previous knowledge. We learned one dimension motion, that is motion in a straight line. We learned about the scalar quantity and the vector quantity, velocity and speed, distance and displacement. Introduction. Today we will learn motion in two dimensions, that is motion in a plane. In this type of motion, to describe the motion of a body, we need to explain it with reference to magnitude as well as direction. Vector quantities. We know those physical quantities which have both magnitude and direction is called vector quantity. How do we represent a vector? Representation of a vector. A vector is represented in the form of an arrow, where we have the magnitude as well as the direction with the help of this arrow mark. Types of vectors. Unit vector. A vector whose magnitude is unity is called as unit vector. And null vector, a vector with magnitude 0 and having direction is called null vector. Equal vectors. Two vectors are said to be equal if they have equal magnitude and same direction. Representation of equal vectors. You can see how the vectors that are equal can be represented. This is vector A, this is vector B. They are equal. You can see the lengths are equal and they are pointing in the same direction. So such vectors are called as equal vectors. Some more. These are also vectors which is moving in the same direction. They are called as collinear vectors. So two or more vectors moving in same direction is called as collinear vectors. Coplanar vectors, that is vectors lying on the same plane. They are called as coplanar. Here we have vector A, vector B, and difference between them is represented by x. All these three lie on the same plane. Position vector and displacement vector. So how do we represent position and displacements? So here we are seeing from the origin, let there be the position vector r1 and another position vector r2. The coordinates of position vector r1 is x1, y1, z1. Coordinates of position vector r2 is x2, y2, z2. So the position vectors of point P is now written as, it is along the x-axis, so its unit vector is I. So we can write it as x1i plus y1j plus z1k, where I, j, k are the unit vectors along the x-axis, y-axis and z-axis. So if we represent the position vector of P in terms of unit vectors, we write it as vector presentation as x1i plus y1j plus z1k. Similarly, we represent position vector R2 as x2, I, y2, j, z2, k. Then the displacement between them, that is del r, is nothing but R2 minus R1. Del r is R2 minus vector R1. That is x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. This is the position displacement vector, and its magnitude is root of squaring x2 minus x1 plus y2 minus y1 the whole square plus z2 minus z1 the whole square. With the help of small example, I can explain this. Look into it carefully. We can see how we will represent when a car is moving like this. So you can see from here 0 to 8 is along the x-axis, so it is written as 8i, and along the y-axis it is somewhere near around 3, so 3j. So position vector at point A is 8i plus 3j. Similarly, position vector at point B, just look at it, along the x-axis is beyond 12, around 13, so 13i. On the y-axis somewhere above 6, let us say 7, so 7j. And if you want to know the displacement, we will minus 13 with 8. 13 minus 8, x2 minus x1, and 7 with 3, y2 minus y1j. And the displacement vector comes out to be 5i plus 4j. So this was a numerical on displacement vector. Resultant of vectors. Resultant of two vectors acting in the same direction or opposite direction, you can see with the help of some examples. Here it is given. Let us say two vectors of magnitude 5 is acting along the same direction. So they are equal in magnitude and direction, so they'll add up and we get the resultant vector as 10. Here one of the vector is in the opposite direction but having same magnitude. So when they will add up 5 minus 5, it becomes 0. Similarly, if we have one vector greater but acting in the same direction, 5 and 10, they will add up giving 15. Similarly, if we have one vector in the opposite direction, that is 5 and minus 10, then we get the resultant as 5 minus 10, that is minus 5. 5 minus 15, that is minus 10. Here they are moving the upward direction, so it is moving plus 10 up, minus 5 down. So then the opposite direction, so their resultant will be subtracted, and the resultant is 5, and it is moving along the upward direction. Thus, we can find out resultant of vectors acting along the same line. The resolution of vectors. They are being resolved in two ways. One is the polar coordinates, and the one is the rectangular coordinates. So, suppose you have a vector A, we resolve it along the x-axis, along the y-axis. X-axis we write it as AXI or A cos theta. Resolution of A along the x-axis is A cos theta, and along the y-axis it is A sin theta. So AX can be written as A along the x-axis can be written as AI or A cos theta into I, and A sin theta j. Rectangular component we write it as AXI and AYJ. In rectangular components we have just x and y. Here we have cos and sine. Now magnitude of vectors. Now if two vectors, let us say vector r, is resolved along the x-axis and the y-axis, then we can say let the x-axis be vector p and y-axis be vector q. So we can write p in terms of r. Here you can see p is equal to r cos theta, because we resolve r in terms of cos theta. So r cos theta, and q can be written as r sin theta. So the resultant r, that is the resultant vector, is squaring p and q. P square plus q square, that is root of r square cos square theta plus r square sin square theta, or that is nothing but r. So r is equal to root of p square plus q square. So the magnitude of this resultant vector is root of p square plus q square. That is x axis square plus y axis square magnitude. Triangle law of vectors. So two vectors are acting along perpendicular direction. That is, one vector ax is going like this, left hand side, another one is going up. Let us say one is moving towards east, another one is moving towards north. Then their resultant can be found out using the triangle law. We draw it in the form of a right angle triangle, and using the Pythagoras theorem, we can say a is equal to root of ax square plus ay square, and that is the magnitude resultant, and its direction theta is written as tan inverse of ay upon ax. This is triangle law of vectors. So in triangle law of vectors, one thing I would like to let you know, the triangle law of vectors we apply only when supposing you have a vector A. Let us say this is vector A, some vector A, and another where we have a vector B. Let us say it is some angle. Now, how to find out the resultant of these two vectors? So we apply the triangle law. What we do is, we take the vector A as usual, and we place vector B on the arrow mark or the head of the vector A. And now we can see, let us say, you know what, this is vector A as usual, and this is vector B. So when we draw these two vectors like this, now it looks as if the body is moving from A to B. This is the direction. This is the direction of the resultant vector. So to find out this resultant vector, we apply the parallelogram law. Now here these two vectors are at some angle. This angle is obtuse angle. So how to find out? In that case, we use this triangle law. We find it out by dropping a perpendicular. We drop a perpendicular and we extend this. The small construction is being done. And then we have a solid, we have a triangle. Let us say this is O. Let us say this is P. Let us say this is the point Q. So we can find out the magnitude R by squaring OP and squaring and adding with PQ square, and then we will get the resultant R. Now what is this? Let us say this is this point is D. So what is DP? So DP can be got by resolving B. We resolve this vector B along DP, it becomes B cos theta. That is that DP, that is the extra which we had been extending and writing, is B cos theta along the horizontal, isn't it? So this DP is B cos theta. So the whole AP will be what do you say, the vector along the horizontal, this is DP. So the whole vector along the horizontal will be now what? A plus B cos theta. So horizontally, now if we write it here, so we can write it as the whole vector OP will be OP, that is the horizontal component total, will be the sum of A vector plus dp, which is nothing but b cos theta. We can write it as b cos theta. Similarly, the vertical component PQ can be written as b sin theta. Therefore, the resultant R we can find out by using the Pythagoras theorem. That is by rooting this square of these two values, that is a plus b sine cos theta the whole square. You have to square both, open the bracket and square, and finally we write down the values by squaring this bracket, adding to b sine theta square, that is b square sine square theta. B square sine square theta. What will we get? We know a plus b the whole a plus b cos theta the whole square. This cos theta here, this theta here, can be written as a square plus b square cos square theta plus 2ab cos theta, and here it is b square sin square theta. So b square cos square theta, b square sin square theta, b square will be left common, and cos square theta plus sin square theta is 1, and therefore we get the final answer R as equal to root of what's left behind, a square plus b square and 2ab cos theta. That is the resultant of this triangle law of vectors. Okay, that is the resultant of this triangle law of vectors when they are at some angles. That's what we are seeing. So we keep them, we place them at the arrow end and we get this. And if the two vectors are at 90 degrees, then the formula is same. We have cos 90 becomes 0, so 2ab cos theta is missing, and then we have just root of a square plus b square, that's written here. Similarly, we can find out the resultant of two vectors with the help of a parallelogram. So next is the parallelogram law of vectors. Derivation is the same, but when do we apply this parallelogram law? Again, we'll be seeing that if there are two vectors, let us say A is one vector and B is another vector at some angle, then how to find out the resultant of these two vectors? So they can be found out by keeping the tail ends together. Previously we are keeping on the arrow mark, now we'll keep the tail ends. Like if I keep this vector A and another vector B at its tail end, see both the tail ends are joined. So this is vector A, and vector B is kept at the starting point of vector A. Now how to find out the resultant? Both of them are moving in different directions. So for this we will draw the parallelogram by drawing a parallel line to vector A. From here we will draw the parallel lines. This is vector A parallel. Similarly, parallel line to vector B. And thus the resultant, now you can see the body is moving from here to here. See, let us say as given here, it is given OP. I'll also write it like that. So this is O, this is P. Similarly, write it as Q. So how is the vector moving now? From O to Q. So that is the resultant vector. So that's what is given here. You can see here. That's given here. Isn't it? Now to find this resultant, what we'll do is we'll drop a perpendicular. So it's done here. So the perpendicular is being drawn. And then we take this portion. This portion again will be this b cos theta, and this portion will be b sine, this portion will be b sine theta, and thus as we had been deriving it, the very same way the derivation will go on here, and we'll write it as a square plus 2ab cos theta plus b square cos square theta plus sin square theta is 1, and there just I had written there it is, resultant is root of a square plus b square plus 2ab cos theta. That is the resultant of this parallelogram law of vectors. Next, we will learn dot product of vectors. How to multiply two vectors. There are two types of product. One is the dot product, another one is the cross product. When to take the dot product and when to take the cross product. So again, let us say there are two vectors A and B. Let us say vector A, another vector B. I want to multiply vector A with vector B. It can be multiplied in two ways. One is by taking the only the magnitude part will come by doing the dot product. How? So we'll again see, let the two vectors be inclined at some angle theta, and A is along the horizontal line. To bring B along the horizontal, we will take the horizontal component, we will resolve B. We'll find out by resolution of B. So when we resolve B, we get it, what do we get here? B cos theta. Because we know on resolving vector B along the horizontal, it is cos of the angle. We just now learned how to resolve the vectors. Similarly, along the x-axis, y-axis, it will be B's sine theta. Now, if I will take this product along the same line, that is A is also along the x, B cos theta is along the x. So, if two vectors are parallel or acting in the same line, then if we multiply, what do we get? A into B cos theta. A multiplied by B cos theta is A, B cos theta. And such a product is called as cross product. Not cross product. Such a product is called as the dot product, not cross product. It is dot product given by A dot, there's a big dot here, and then B. So when we write vector A dot vector B, it means we are multiplying vectors along the same line, and it is given by AB cos theta. So that is what is given here. So A dot B is equal to A dot B is given as what? AB cos theta. So when we take A as AXI, I write vector A as AXI, AYJ, AZK. Now I'm writing in terms of its three coordinates, and vector B as BXI, BYJ and plus BZK, and when we multiply both A dot B, it is AXI multiplied by BXI, it means I dot I, it means I cos theta, and theta along the x-axis, if I bring B over here, theta is 0, so cos 0 is 1, so I dot I is 1, J dot J is 1, K dot K is 1. So when we write them as AXI into BXI, it becomes AX BX. Similarly, AYJ into BYJ becomes AY BY. Similarly, AZK into BZK becomes AZ BZ. And IIJJKK becomes 1. But I dot J, that is, if I will take this is along, I'll bring the pen again. So this x-axis unit vector is I, and y-axis unit vector is J, and along this z-axis, this is the z-axis, the unit vector is K. So we write down as unit vector is written as in terms of caps. We have to put a cap here. This is the cap. I cap, j cap, k cap. Now, when we multiply I with j, it is ij sine theta. Ij or ij cos theta. You can see now. What do we write? I dot j. So it is ij cos theta, and here angle is 90 degrees. Cos theta, if I take, here theta becomes what? If I go from I to j, the angle becomes 90 degrees. See, from I to j you go 90 degrees. So I into j into cos of 90, cos 90 is 0. So I dot j becomes 0, I dot k becomes 0, j dot k becomes 0 because we are throughout multiplying with cos 90. Theta is 90. So in dot product only we have the magnitudes and no vector, and therefore A dot B can be written as its magnitude. So with the help of scalar product or the dot product we get the magnitude. Going to the next slide. Now two vectors are perpendicular. What is the condition? So when the dot product is 0, then two vectors are said to be perpendicular. Just now we saw A, B cos theta. If theta is 90 degrees, then cos 90 is 0, and therefore A dot B becomes 0. It means cos of the angle between A and B is 90 degrees and cos 90 is 0, and then we can say that that is a condition for two vectors to be perpendicular to each other. Next, angle between two vectors. How will you find out? To find out the angle between two vectors, again we are coming to the formula that A, B cos theta. Just now we learned the formula. I'll once again recollect the same formula that we were writing now, the scalar product, that A, what were we writing? I'll just take this pen and try to let you know what I was trying to say, that it was A dot B, which was equal to A magnitude of A, magnitude of B into cos theta. So if you want to know the angle theta, so keep cos theta one side and bring rest of the things other side. That is, this is vector. You should put a vector sign here. So what will we write down? Vector A dot वेक्टर बी, यानी कि दोनों को जब मल्टीप्लाई करते हैं जो निकलेगा उसको जब हम ए और बी के मैग्नीट्यूड से डिवाइड करेंगे, मैग्नीट्यूड पार्ट से डिवाइड करेंगे, मैग्नीट्यूड ऑफ वेक्टर ए मल्टीप्लाइड बाय मैग्नीट्यूड ऑफ वेक्टर बी, तो हमें क्या मिलेगा? कॉस ऑफ द एंगल. So to find out that, we'll go like this. Let us go and see this. And to write out magnitude of A, magnitude of B, so magnitude of A can be written as root of, how do we write down magnitude of A? Root of ax square plus ay square plus az square. Magnitude of A can be written as root of ax square, A along the x-axis, square of it, plus A along the y-axis, and A along the z-axis. Squaring it and rooting it, we get the magnitude of A. Similarly, we can find out the magnitude of B. Vector B's magnitude will be again like this, by squaring and adding all the three axes depending on the root of it. So it will be B x square plus by square plus bz square. So we know the magnitudes, we know the dot products. When we will multiply them, just now we saw it was AXI, AXBX, AYBY plus AZBZ. That was the dot product, and this is the magnitude. And when we write all this, we can find out the angle between two vectors.